The last of our groups of ions that we will get observations for are the halides. So we've already looked at hydroxides and carbonates, our two alkaline anions. We've looked at sulfates, which precipitate or make a go cloudy with barium ions. In this one, we're going to look at the halides. Now, halides are group 17 ions. So actually in order, it'd be fluoride, chloride, bromide, iodide. In this assessment, we're only going to look at chlorides and iodides because they have probably the easiest to determine observations. Fluorides are probably a more common source of water pollution in urban areas, and bromides give two similar observations to iodides, so we don't use those for this assessment. So we're going to try and tell if we've got a halide first, and then which one is it. So what I've got here are two solutions. I've got my chloride, so in this case it's potassium chloride, because potassium ions are always soluble, and I've got potassium iodide, because potassium ions are always soluble. So because potassium ions are always soluble, they are spectator ions. They're not going to react. They're not going to do anything. So the first step when we do this analysis is we always start with a piece of litmus paper to just rule out the alkaline anions. So drop those in there, make sure they actually touch the solution. And they stay red. Remember, if they go blue, it's worth doing it again just to check you didn't have impurities in your test tube. Make sure you clean them out well enough. But they've stayed red, I can be really confident that that's right. Okay. Then the next step would be to rule out sulfate. So in this, it's not just about what is there, it's what isn't there. So we rule out sulfate by adding barium chloride to the two of them. And they stay clear. He says with hope. He's cleaned them out well enough. So because they stayed clear, they didn't precipitate, it is not sulfate either. So I've now eliminated hydroxide and carbonate because the litmus paper didn't go blue. And I've now eliminated sulfate because there was no reaction with barium chloride. So I don't have to write any chemical equations yet because nothing's happened. It's done a whole lot of nothing. So I'm going to get my barium chloride out of the way. At this stage, if you were to add anything else, there are now impurities in there from the things we've put in. So we actually have to start with a new sample. And I'm one test tube short, so I'll grab one of the ones I cleaned earlier. So this is why this one takes a bit more time. You need to take some new samples. So here's my chloride, and here's my iodide. I'm trying not to use more than about 1 centimetre height. Less is better, actually, but for the video I'm trying to use a bit more so you can actually see what goes on. The next step in the flow chart tells us that we need to add a couple of drops, and please only a couple of drops, of silver nitrate. If these go cloudy, it means they are a halide. They're one of these. And for this assessment, that means chloride or iodide only. And it should only take 2 drops. It doesn't have to go as milky as we saw the other stuff. It just needs to go a little bit cloudy. And that is the observation we're after. And hopefully that can be seen on the video. I might just bring it a bit closer. You can definitely see the chloride. It's a little bit harder to see the iodide though. But they have gone a little bit cloudy. That's all it needs to be. Now, then you have to go, well, which halide is it? And for this, you need some ammonia. What is made is a thing called a complex ion. And I'll do the equations for these in a moment on the board. So if I add lots, and I mean lots, of hydroxide to something, and it disappears, and this one should, so it goes clear again. I've got too much of my chloride in there, I think. Then if it disappears, it should be a chloride, and nothing should happen to the iodide. So I've got too much in that, so I'm just going to quickly do that one again with the sorts of volumes I should use. So I really should only be using a very small volume. Couple of drops, and then it's a decent squirt of my ammonia. There we go. That's what we expect to happen. And it goes clear again, which is pretty cool. We call that redissolving. Okay, that's the word we use for describing that. So now chloride does redissolve, but the iodide does not. It stays cloudy. That's how we tell these two apart. Iodide stays cloudy, chloride redissolves. How do I show that in an equation? So, first of all, we have to show the precipitation. So let's say we had chloride. It's Ag+, because that's the ion that matters in silver nitrate, because all nitrates are soluble, plus chloride going to silver chloride, which is a solid. Then, this one does redissolve, and it's reacting with ammonia, which is NH3. And it makes a thing that's going to be new for you to learn about, which is called a complex ion, which has got square brackets around it. And you are given the formula for these, and it's the silver diamine complex. You don't need to know the name, you just need to know that this reacts with the silver only, not the chloride. And it's got 2 ammonia molecules bound to the silver ion, so that because they're molecules, they have no charge, which means that it keeps the same charge as the silver. To balance this, I've got to have the chloride over here as well, and chlorides have a -1 charge. This is one of your excellence level, merit and excellence level equations that you need to be able to work out, because you are given this, that you need to work out the rest of it. It's not balanced yet. I've got 2 ammonias in this, and I've only got 1, so I put a big 2 in front of this one to say that there are 2 molecules of that. There are others that will do where there are 4 ammonias that react with it, so it'd be what we call tetramine. For iodine, this reaction, for iodide, poor grammar, for iodide this reaction doesn't happen. For iodide, the only reaction you'll have is silver ions plus iodide ions going to silver iodide. And then no further reaction because it's stayed cloudy. And it actually gets cloudier the longer you leave it for this one. And maybe it's a little bit of a yellow tinge. So iodide and chloride, our halides, are probably our hardest ones, and they, very unsubtle hint, give a very, very good opportunity to get to excellence level. So they're a good one potentially to be in an assessment. Anything that has a complex ion is a good one to have in an assessment. Doesn't mean we're going to use it. We might use a cation that has a complex ion instead. So there's halides.